Hello everyone. In this tutorial video, I like to explain how to factor polynomials, as well as give a recap of how factoring works with normal arithmetic. With traditional arithmetic, you may recall that factoring means finding all of the numbers that you have to multiply in order to get the result you are factoring. For example, 12 factored is 4 times 3, so 4 and 3 are factors of 12. There is also a special type of factorization called prime factorization, where you break the numbers up and to have only factors of 1 and itself, which are always called prime factors. So we can rewrite 12 as 2 times 2 times 3, because 3 and 2 cannot be broken down any further. So it follows that we can factor algebraic expressions the same way, by figuring out the largest number, when multiplied, fits into all the terms, known as the greatest common factor, in order to simplify it as quickly as possible. As in this example, we can see the integer factor is 2, and the variable factor is x squared, so we factor 2x squared out of everything. However, the catch to this is that this is not the full or prime factored form, and we will instead have to use a more tricky method known as the AC method, which only works for quadratic expressions, or expressions of the form ax squared plus bx plus c. So if they have any more or any less terms, it will not work. The AC method is asking yourself what numbers are multiplied to get the third term with no x on it, but add up to the second term with an x on it at the same time. And also paying attention to the first terms of each factor having to multiply to give you ax squared exactly in the original equation. So it is called the AC method because you have to figure out what factors when multiplied give you a and c exactly, and who add up to b. For example, if you factor this polynomial, you see that negative 15 is the product, 2 is the sum, and we see 5 and negative 3 are the candidates. So we have to do something plus 5 and something minus 3 as our factors. We see that they have to be x exactly, the first terms in each factor, in order to get x squared, with only 1 as the coefficient. We conclude that the full factorization is x plus 5 times x minus 3. If we have something more problematic, i.e. where a has a coefficient different than 1, like this, we would have to multiply a and c. So in this case, we're having a product of negative 24 rather than a product of negative 8. And we see 6 and negative 4 give us this product and add up to 2 as well. So now we have something plus 6 times something minus 4, but the catch is here, it cannot be x's exactly, because we now have a coefficient of x greater than 1. So what we do is, we remember what the distributive property is, and see we are applying it here to get the result of what we were factoring in the first place. So although we know that 3 times 1 cannot be factored any further, so one of the factors will have to be 3x, we do not know where exactly 3x will go, i.e. if it's in the first term or the second term, which is where the distributive property steps in. We see with some careful reasoning the distributive property with something like this is the first term multiplied by the first term multiplied by the second term, and then repeat. So the second term multiplied by the first term, and the second term multiplied by the last term. So we see with some careful reasoning, if we multiply the 3x by the 6, we get 12, or more accurately 12x. And if we multiply x, or 1x, by negative 4, we get negative 4x. So in the final product, we add these like terms. 12x minus 4x equals 8x, which is what we had in the original problem. So in conclusion, we have to be specific about tacking the 3x on negative 4 so that it multiplies out on the 6, because if we did it on the other factor, we would get a different result than 8, which you can verify is true by doing the distributive property steps. Although this kind of method only works for quadratic formulas, we can factor formulas larger than quadratic formulas simply by finding a way to simplify it into a quadratic formula by taking out greatest common factors and stuff like that, and then using the quadratic factoring method on the result to get it in its most simplest factored form. Now that we've figured out how factoring works for polynomials, we can figure out how to deal with ratios of polynomials called rational expressions next. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.